Okay, good morning class. At this point we're still looking at trigonometry, trig graphs. You guys had some homework, correct? The homework was exercise worksheet 12A, correct? Huh? Okay. Worksheet 12A. So the question says, draw the graphs of the following for x in element of 0 to 360. So as I told you before, we now don't need to have all those units in between. For the sine and cos graph, it must be steps of 90 degrees. For the tan graph, it's going to be steps of 45 degrees. Okay. So what we do is we can actually put this in the calculator as well. So what we do is 1.1 I think I must just get the graph, credit page. Okay. So when you put in the calculator, you press mode. So you guys can follow through. Press mode. Alright, your calculator's on. You press mode. Nice. Alright, so now you're going to press 7. The table. You're going to press 3 or 2. What number are you pressing? 2. 3. Sam is pressing 3. Anybody pressing 2? No? Okay, you guys have bit calculators. Now, we're going to enter the function, which is 2 cosx. You say 2 cos x. You see in maroon here, can you see that, people? So I press the alpha button, x, close. Okay. Then you press equal to. Some of you will get a g of x, which means to say you can enter second function. I'm not interested in that. It's equal again. Where are we going to start? Where do you think we're going to start at? 0, yes. Till? We're going to end at 360. Now the steps is the units in between. So the steps for the sine and cos graph is going to be 90 degrees. Not so. I can't go with the 1 because it's going to be, the calculator doesn't have so much memory. Okay. So, the 2 cos graph, 0 corresponds with 0. Can you see, with 2, sorry. Can you see that? Just align the board quickly. Sorry. 0 corresponds with 2. 2 corresponds, 90 corresponds with 0. 180 corresponds with negative 2. 270, 0, 360, 2. So what do? Connect the dots. It's better if you can actually do this without the calculator. But since you are still at the beginning stages of this graphs, sorry. So just to get used. Okay. So that's the 2 cosx graph. Not so. So what is the amplitude of this graph? The amplitude is 2. Not so. The amplitude is 2. The period of this graph, 360 is. The range of this graph, the range is from -2 to 2. So y is greater or equal to -2, but less than equal to. Okay. The next graph, 1.2, negative 3 sin x. Again, mode 7, negative negative 3 sin x. Alpha patterning equals, we don't have a g of x. We're going to start at 0, we're going to end at 360 and steps of 90. So 0 is with 0. Not so. 90 is with negative 3. Not so. 180 is 0. 270 is 3. 360 is 0. Again, without a ruler, freehand. Connect the dots. Okay. Considering we're drawing the turning points in as well. So it's negative 3 to 78. Okay. 1.3. Same story. Enter in the calculator. Tanx. Now we say AC. AC again. So Tanx. Alpha equals start at 0 to 360, but now you put steps of 45 degrees. Okay. So 0 is 0. 45 is 1. 90 is an asymptote. Not so. 135 is negative 1. So what happens is that point. And importantly that I draw this here, this coordinate in. Okay? 180, 225 is 1. 270 is undefined again. Okay? So, is that graph? It's negative. You all okay with that? Sorry, man. That is plus 2, cosx plus 2 then. Again, we can enter that into the calculator. AC twice. So it's cos x. Importantly, I close the bracket after that. Otherwise, you're going to put the plus 2 as part of the angle. Okay. Start at 0, 360. You could have gone steps of 45. But I only take the rational values. Okay. So that gives us so 0 corresponds with 3, 90 corresponds with 2, correct? Is that correct? 180 with 1, 270 with 2 and 360 with 3. Connect the dots. So that is going to be 180 and 1, 360 and 3. Okay. What is the range of this graph? It's from 1 till 3. So y is greater or equal to 1, less than or equal to 3. What's the period of this graph? 360. What's the amplitude? 3, 2, 1. What? Which one? The neutral is this point here, not so. So from the neutral or the middle to the maximum is 1. The amplitude is 1. It's the middle part. No. Remember, what did we say? What is the amplitude? You're looking at the sine graph. That's your x-axis. That is your amplitude. The measurement of your amplitude. Can you see? Now this was normally 0 and that was 1. But now the graph is shifted. So that is the middle of the graph to the maximum. And that distance is 1. So the amplitude is 1. Okay. You can even take it from the number in front of you. This is also 1. What's the amplitude of this graph? 1.5. It's going to be 2. You'll see now when I draw the graph. Okay. What's the period of that graph? For this one? It's 360. 1.5. So that is the negative 2x graph minus 1. Again, you can plug this in the calculator. So AC twice. So negative 2 sine x minus 1. And we take the rational values between. Can you see that? Okay. Now I'm going to show you, I'm going to draw the graph without that name. So what I do is I say, okay, this is the sine graph. That's basically what the sine graph does. Not so. By 1 and minus 1. Not so. But if it's 2, what would 2 have? What effect does 2 have on the graph? It's enlarged by a factor of 2. What effect does the negative have on the graph? Goes down then up. Graph is deflected in the x-axis. And then the graph, so you go down and up. So that's going to give you 2 and minus 2. Then the graph goes down by 1 unit. So if I draw this, that point there, consider this point, and I go down 1 unit, it goes to minus 1. Then I consider this point, which is 19 minus 2, becomes 19 minus 3. That is 180 and 0, becomes 180 and minus 1. This is 270 and 2, becomes 270 and 1. This is 360 and 0, becomes 360 and minus 1. There is a graph. And this is what you will master as time goes on. And the more graphs you draw, you will be able to draw this without the use of a calculator. And these endpoints, since it's not on the axis, I must draw it in. This 270 and 1. This is going to be 90 and minus 3. Do you see? What is the amplitude of this graph? Let's see here. Amplitude is from the neutral, from the middle, which is this here. You will agree this is the middle, to the maximum. What is that distance? 2. So the amplitude here is 2. Hence, that's what I told you earlier. What's the period? 360. What's the range of this graph? From minus 3 to 1. So y is greater than or equal to minus 3, but less than equal to 1. Okay? Any confusion there? Let's take a calculator over here. Let's see what's happening behind there. Whoops. You get 1.6, 2 tan graph, 2x, tan, 2 tan x, tan 2x. So that, at 0 is 0, at 45 is 2. We write at least 1 point in here. 90 is an asymptote. It's 45 and 2. 90 is an asymptote. 270 is an asymptote. So that's what the graph is. As you can see, the graph is stretched. Okay? We enlarge by a factor of 2. You all agree that's the graph? No? The 2 tan x. And then draw the on the axis here. Y is equal to, so what's going to happen if there's a negative in front of 10? It's going to be reflected in the x-axis. Remember the sign, this is the sin x graph, not so. So if it's y is equal to negative sin x, what happens to the graph? It goes down then up. Same size. Can you see that? So that part becomes that bottom part. Can you see? So it's reflected in the x-axis. And if something is reflected in the x-axis, what happens? All the y values becomes negative. So the negative becomes positive and the positive becomes negative. Okay. That's something to remember there. So if I put that in the calculator, 0 is 0, 45 is negative 1. Then you see asymptote here. 135 is 1. Remember to write at least 1 point on the tan graph. Okay, so 135 is 1, 0, minus 1. Okay, and then that's going to be 118. This is the y is equal to minus 10x. I know they didn't ask you to draw this in x. I'm just drawing it here. 1.8. Take a calculator already. Tan of x, tan of minus x minus 1. So remember, what's going to happen to this tan graph? It's going to go the other way around. Goes there. Right? And then minus 1. Nope. That one is wrong here. Actually the other way. So it goes down, down, and down. Okay. I still used to move. Okay. Then the graph, that tan graph then moves 1 unit down. Okay, so we can draw this graph. Now number 8. So 0 and 0 becomes 0 and minus 1. As it moves 1 unit down there, the asymptote remains the asymptote. So if you move the asymptote, that graph 1 unit down, it doesn't affect your asymptote at all. So 45 and minus 1 becomes 45 and minus 2. Again, right at least 1 point. So there's that graph. That section of the graph. 180 is normally 180 and 0. So there's that one. 135 and minus will be 1. It will be 135 and 0, 135 and 0. 2 to 5 will be minus 1, so right now it's going to be minus 2. So the graph will be over there. And that part of the graph will be shown. Okay? 360 is normally 0, it becomes 360 and minus 1 now. That's the end point, so I'll draw it in. Okay? That goes into. As you can see, the graph is repeating itself every. What's the period on the tan graph? 360, 180. Okay. The number 9, you got 1.9. You got negative sin x plus or half. So the negative sin x graph will do that. Not so plus or half will shift this graph 1 unit, a half a unit, up, yes. So that point there goes to a half. So I put that on the diagram because it's not on the axis. This is 90 and minus 1 becomes 90 and minus half. One 80 and 0 becomes 180 and a half. 270 and 1 becomes 270 and 1 and a half. Because I moves 1 unit up. Half a unit, sorry. And 360 and 0 becomes 360 and half. That, as you can see, is the end point. That's why I'm drawing it here. Again, just connect the dots. And there we go. Okay? Sketching the graphs normally 3 or 4 marks. Okay? Yes? Sorry? Yes? Didn't I? How couldn't I? I probably sent it the wrong way. Then now I sent it. Check my. Okay, so let's go to number 2. So here, question says determine the equation of the following graphs. Okay. Didn't I give a reference here as well? No. Right, so now we're looking at determining the equation of the following graphs. So you all see this is a sine graph. Let's start at 0 and move on, half unit. Where it's moving half unit. No, the normal sine graph does that, not so. But what you notice is at 0, it's gone down to a half. Can you see? So what is that Q value? Negative, so moving down. So they determine the equation, so y is equal to sin x minus r. Now let's act dumb. Okay, you say, okay, we didn't know that. I'll show you how to do that. Okay, it was easy for us to do that, no? You act dumb and you say, okay, we didn't know, we didn't get the PDF, or something like that. No? It's easy to say. So, what do we do then? Say, okay, we'll substitute the point that's lying on the graph, which is, the known point to us is 0 and minus r. People, that is points on the graph, but that is not known to us. We don't have the coordinates, not so. So what do we do is we substitute 0 and negative 0.5. Remembering that's an x and a y. So negative 0.5 is equal to sine 0 plus q. Okay? Now you put in your calculator, sine of 0 is 0. So q is negative 0.5. So therefore y is equal to sine x minus r. Okay? Yes? Y is equal to? Negative sine x now. You must remember this is your 0 here. If it was, she's saying, mustn't it be y is equal to negative sine x plus minus half? Is that what you're saying? Right. So, if it's negative sine x, the graph is going to go first down then. Can you see? What do you notice about this graph? First going up. Remember, that is part of a graph we always draw. But they have included this part. Can you see? So they only took this part. So the sine x, this is the normal sine x graph. They only took that part of the graph. And then the 180 on the other side. Does it make sense? Why not negative? Right. Look at number 2. This is the cos graph. Can you see it's a cos graph? Right, so the cos graph normally starts at this negative, at this maximum. Not so? On the y-axis. And there you get this negative cosx, so that the graph goes from minimum now. Remember the cos graph? So what I do normally now, I draw the graph on the side and say, okay, that is the normal, that is cos of x to me. Not so? Then we say, okay, what happens to the graph? The graph is inverted. So that is going to be negative cos x. Okay, and that is not normally 90, not so? You all agree with that? So this graph is gone down to 60. So this graph is actually shifted up by a certain amount of units. When I move down, and at that point they will become great terms with that y x intercept. Now I don't want to guess. I think it's going to be off. Okay. But again, it's not going to be safe for us just to guess. Okay? I said I wasn't going to guess, and I guessed anyway. Alright. Jesus. Right, so what do we do? We substitute that point into that. So let's substitute. What's the coordinates of this point? 60 and 0. That's a x and a y. So 0 is equal to negative cos 60 plus q. Can you see that? So cos of 60 is what? Put in your calculators. Half. So it's going to be, you take a half over the equal sign, becomes positive half is equal to q. So the equation is y is equal to negative cos x plus. You guys understand? 1.3. Now here's no, what's the name given here? Okay. Let's check here. Normally they give us the equation or an idea. As you can definitely see, it's a sine graph. Okay, it's not given there. But you all agree it's a sine graph. Huh? How do we know that? Because that starts at 0. It starts at in the middle. No? Then it goes to 90 and 1.5 and then you get 9. Now, is this going to be a positive or negative sine graph? Positive. So the equation of this graph is y is equal to sine x. Okay. But is this graph shifted? Is the sine graph shifted? How do I know it's not shifted? Because it's starting, it's going through 0. If the graph is shifted up or down, you must go, you will cut your y-axis at a place other than 0 then. Not so. So there's no shift, vertical shift on this graph. So it has a amplitude change. From here we know that the amplitude here is what? 1.5. So your A value is 1.5. That is the equation that should have been given to you. Okay? So it's going to be y is equal to 1.5x sine x. Now say for instance that wasn't given. Let's say we can't just read the graph like that. Let's act dumb and say, okay, yo, we don't know what's this is difficult and all of those things. And that is the equation given. Okay. That's the equation. Where do we start? We first yawn, yes? Good start. Repeat that. Nice. You substitute one of the points. You always go with the 0 and 0 first. Let's substitute the origin, which is 0 and 0. It's an x and a y. So 0 is equal to a sine 0 plus q. Okay. So what is sine of 0? 0. So 0 times A is 0, so Q is 0. So we have now y is equal to A sine x plus 0, which is exactly that. So how do we calculate A now? How do we calculate A? You substitute the point that's lying on this graph. Not so, which is 90 and 1.5. So now you substitute 90, 1,5. Remembering that's an x and a y. So that's 1,5 is equal to A sine 90. What is sine of 90? What's sine of 90? 1. Not so. 1 times A is A, so A is equal to 1,5. So therefore the equation of this graph is y is equal to 1,5 sine. Okay. You see how our little work is needed if you know the characteristic of the graph. Okay. Look at this graph. Which graph is this? Cos graph, not so. Again, I can write this graph down straight. That it's going to be y is equal to negative 3 cos of x. Now again, let's say we didn't know that. Okay, so, and the equation is given as y is equal to a cos x plus q. So where do you start? Where do we start? We substitute one of the points. Let's go with 0 and minus 3. Remembering that's an x and a y. That's all. So your y value is negative 3 is equal to a cos of 0 plus q. What is cos of 0? Lekker. How will you get 0? Put your calculator down, use your heads. Still 0. 1. So a plus q is equal to negative 3. And this equation, why am I labeling the equation? Because we're going to go into simultaneous these two unknowns. Can you see that? So now what we do is substitute the other point. What's the other point on the graph? 90 and 0. Again, that's an x and a y. So I'm just going to go back into the original equation. So what do I substitute? 0 equals a cos 90 plus q. What is cos of 90? 0. 0 times a is 0. So q is 0 in this equation 2. Now we can sub that back into the. So what do you notice now? Negative 3 is equal to a plus 0. So a is negative 3. Therefore, y is equal to negative 3. Okay. Something like this, 2 marks. Okay? Because I can be just looked at the diagram. If you had done enough of these graphs, you can derive the formula easily. Okay. Carry on with our lives as if we had the homework done. Yeah. 2.5. And there we go again. So, what do we do first? We substitute. We substitute one of the points. Let's go with 150 and 150 and 0. So that's going to be 0 is equal to a sine 150 plus q. What is sine of 150? Half. So this will be half a plus q is equal to 0. So q is equal to minus half a, or a is equal to negative 2q. Okay, this equation. So what do we do now? We substitute the other point, which is 90 and 0,5. Again, that's the x and the y. So 0 is equal to, I'm going back into the original equation. 0.5 is equal to a sine 90 plus q. What's the sine of 90? 1. So that's going to be a plus q equals 0.5. And this is equation 2. What do you do now? We substitute. Wherever we see q, negative arm. So we say therefore 0.5 is equal to a plus minus a half a. What is a plus minus half? A half. Not so? So a half a is equal to 0.5, which is also half, so a is equal to 1. Okay? So what do we do with that? Sub that back into where we got q as the subject of the formula. So q is equal to negative half times 1, which is negative. So the equation of this graph is y is equal to a is sine 1, so it's going to be sine x minus 1. Okay, so if I just draw that graph, that is what your sine graph looks like. Not so. That is 90 and 1, and that this is 180. Not so. But what happens to the graph, as you can see, if I shift this graph one half unit down, then this becomes 90 and a half. Okay, and this point here becomes somewhere there. Okay, so we're moving down. So yes, it does make sense that the graph could be y is equal to sine minus 1. Okay. Homework. I would like you guys to do worksheet 12b. The whole worksheet, okay? It's quite a bit for the weekend, okay? We will enjoy the rest of your day and the weekend. Good morning, class.